Six blind elephants. Categories of categories. Chapter 5. Dividing and binding bundles. Logical levels. Intelligence organizes the world by organizing itself. As we discussed in Chapter 2, the simplest basic level category is a bundle of experiences. As we discussed in Chapter 2, the simplest basic level category is a bundle of experiences which are selected using criteria and collected together into a database in our internal experience. The collection is usually accomplished by representing them in the same general location in our personal mental space. The collection is usually accomplished by representing them in the same general location in our personal mental space, using a certain set of perceptual qualities, size, brightness, 3D or flat, moving or still, etc. These are called submodalities because they are smaller elements within each modality. When we think of the examples in the group, we may experience them simultaneously as if looking at a collage of images, or we may experience them sequentially, one after another, in rapid succession in the same location. A basic level category often acquires a name, a word that we use as a kind of filing system and for communicating with others. The name itself is arbitrary and quite different in different languages. What is important is the group of experiences that the word indicates. When we recover the meaning of a word, we can scan some or all of the examples in the category. But more often we use prototype to represent the entire category because it is so much faster and easier. If our ability to categorize stopped with these basic level categories, our lives would be much simpler and a great deal less interesting than they are. Fortunately, we can also subdivide basic level categories into more specific categories and or group them together into more general categories, creating logical levels of categorization. For instance, most people will readily agree that the basic level category chair has more specific subcategories of easy chair, straight-backed chairs, recliners, lawn chair, etc. Chair is also a subcategory of more general category furniture, which could also include sofas, tables, bookshelves, etc. Furniture could in turn be a subcategory of some other more general category, such as objects, man-made things, things that weigh less than a ton, etc. This ability to organize categories is one of the most resourceful and remarkable characteristics of human intelligence. It is very fast and efficient, and usually serves us well in both understanding the world and communicating the understanding to others. But at other times, when it doesn't work so well, it is useful to make the process conscious so that we can examine it and adjust it. In order to begin the process of understanding, I would like to present a very simple example of how we create categories that are composed of other categories. Imagine that someone spreads out a group of about 70 small children's blocks. Imagine that someone spreads out a group of about 70 small children's blocks on a table in front of you and sets you the task of describing the blocks themselves, ignoring their location and orientation, to someone else over the telephone. What you might notice first is that each block is either all red, all white, all red, all white, or all blue. Next, you might notice that the shape of a cross-section through the block is either square. Next, you might notice that the shape of a cross-section through the block is either square, round, or triangular. Finally, you notice that each of the blocks is either 1 high, 2 high, or 3 high. If you were to pick out one block, describe it on the telephone, and then pick out another and describe it, etc., that would take a long time. It would be much more efficient to put them into categories and describe the characteristics of each category. You could also start by grouping all the blocks into 3 different categories, using color as criterion. Then you could subdivide each of those groups into more specific categories based on their shape: square red, triangular red, circular red, etc. Finally, you could subdivide each of these groups into more specific categories using height as a criterion. We can show the resulting categories using a tree structure diagram shown on the next page, using S for square, T for triangular, and C for circular. This categorization would yield 27 of the most specific categories. If we had started by dividing the blocks into the most specific categories, we could then have put them together into more general categories to create the same ordering. Blocks red, white, blue. Page 96 presents us with a picture or a diagram or a graph. I'm not going to describe it. However, if we had started our classification with height and then used color and finally shape, we would get a different sequence of categories as follows. It's another graph. The most specific categories would remain the same, and the most general category, blocks, would remain the same, but the intermediate categories would be quite different. Levels of categorization depend not only on our choice of criteria, but also on the sequence in which we apply those criteria. Research has shown that we begin our lives by creating basic level categories based on everyday experience. Then we either subdivide them into more specific subcategories or group them together into more general categories. Notice that I have been using the terms more specific and more general for categories rather than smaller or larger. A more specific category usually has fewer examples and might be called smaller, and more general categories usually have more examples and might be called larger. However, since I want to make a clear distinction between scope and category, I use smaller and larger to describe scope, and more specific and more general to describe categories. Categorical inclusion. This kind of arrangement is called class inclusion by mathematicians because every member of more specific class is also included as a member of any more general class. For instance, a 1-inch square white block is also a member of each of the classes: square white blocks, and blocks. The relationship between classes can always be represented by a tree structure, like the one above. Since class has a very specific meaning in mathematics, and I am not a mathematician, I will use the more general everyday term category, an ordinary word that most of us naturally use to organize our experience. And I will also use categorical inclusion instead of class inclusion. Using the ordinary word category also follows the usage of lack of in describing research on linguistic categories, and Edelman in describing research on the neurological basis of our ability to categorize. Notice that a category of blocks is a group of blocks, not a single block. So it is not a member of more general category of blocks. Only the members of a category of blocks can be members of a more general category of blocks. Only the members of a category of blocks can be members of a more general category of blocks. The category of square white blocks is not a member of category white blocks, but the individual square white block included in that category are members of the category of white blocks. A group of cows is not a cow, it is a herd, but the members of the herd are cows. However, a category of blocks could be a member of the more general category, categories of things or concepts, etc. This may seem like an obscure point, but the lack of distinction between a group of things and the things themselves can be a source of confusion, and I want to be very clear about this at the outset. Another source of confusion is the difference between the name of a category and an individual member of the category. The word cat can be used to indicate a category of animal, or it can indicate an individual member of the category. You can pet an animal, but not the word. The word herd is neither a group of cows nor an individual cow. It is only a label for a group of cows. The names of different foods offered by a restaurant can be indicated by a menu, but that piece of paper tastes very different from any of the foods and is considerably less nourishing. Categorical inclusion is the simplest way to create an ordered sequence of categories to describe a group of things or events. And it also the basis for the simplest kind of logical argument, as in the classic syllogism, all men are mortal. Socrates is a man. Socrates is a man. Therefore, Socrates is mortal. Since Socrates is a member of the category of man, and the category of man is included in the category of things that are mortal, Socrates must be mortal. This can be shown using a simple Venn diagram of circles. The large circle includes all things that are mortal. The smallest circle inside that includes all men. And the X inside that indicates that Socrates is a member of the smaller circle. Similarly, we could say all chairs can be sat on. All chairs are members of the category things that can be sat on. This X is a chair, therefore X can be sat on. Using the same diagram, the large circle now includes all the things that can be sat on. The smaller circle includes all chairs, and the X indicates a particular chair. Inheritability. We can draw this kind of logical conclusion because any criterion for a more general category has to apply to any more specific subdivision of the category. When we divide the category of white blocks into more specific categories based on shape, height, or any other criterion, the members of these categories all have to be white blocks. This has been described as a property of inheritability. Notice that inheritability is unidirectional. It only applies as we move from a category to a subcategory. If we move in the other direction to a more general category, heritability does not hold. For instance, if we go from category triangular white blocks to more general category white blocks, some of those would not be triangular. Likewise, if we include the category blocks in the more general category toys, many other toys would not be blocks. Constriction. Each subdivision of any category is based on one or more additional criteria that further specifies the examples that can be included in the subcategory. This has been described as the property of construction, because each additional criterion for a division constricts the kinds of examples that can be included in it. For instance, the category of 2-inch triangular white blocks usually has fewer members than the more general category white blocks, which could also include square white blocks and circular white blocks. However, if there were no square or circular white blocks in our particular pile of blocks, the two categories would have the same number of blocks. Logical levels describe the different levels of category created by categorical inclusion. It is the principle used in everyday logic, and it is also one used by Bostic and Grinder, which they call logical inclusion, a term which is only occasionally used in mathematics. The term logical levels, as used rigorously in mathematics, is somewhat different, and we will take up that topic later in this chapter. Ordinarily, every category includes examples, so we can use the word example and include to determine whether or not two events or categories are related to each other by logical level. If Y is an example included in X category, then X is a more general category at higher logical level. A member of the category cow is included in the more general category mammal, animal, or organism. Similarly, if X category includes Y as an example, X is a more general category at a higher logical level. The category mammal, animal, or organism includes a member of the category cow as an example. The term higher logical level is often misunderstood to mean that more general categories are always more important, as in higher values. A more general category may or may not be more important or useful than a more specific one. When it is more important, that results from something called relational criteria, which will be discussed later. The word level also presupposes that some levels are higher than others. Again, we need to realize that this does not necessarily mean that they are more important. Now, I would like you to be aware of your internal images as I describe some examples of levels of categorization. A basic level category, like keys, might be composed of a group of sensory-based experiences, creating a category that we can arbitrarily label logical level 1. The category keys could also be a member of a more general and abstract category of experiences, such as touch, which would include a number of other kinds of touching, such as nudge, caress, tap, stroke, etc. Touch in this description is a category whose members are also categories, rather than sensory-based experiences. Since the examples of the category touch in this description are categories at logical level 1, we can call this logical level 2. Notice how your image of touch is less specific and detailed, more abstract, than your image of a kiss. However, the category keys could also be subdivided into more specific categories based on quality, intensity, warmth, or some other criterion or set of criteria, into peak, passionate, obligatory, etc. If these names refer to categories that contain sensory-based examples, then these categories would be at logical level 1. The category keys would now be at logical level 2 rather than 1, and the category touch would now be at logical level 3 rather than 2. If these names refer to categories that contain sensory-based examples, then these categories would be at logical level 1. The category keys would be at logical level 2. I see. Now, the different subcategories of keys are abstractions from sensory-based examples, and keys is composed of categories of categories. Touch is at logical level 3, is a category of categories of categories, still further removed from specific sensory-based experience. However, someone else might categorize very differently. For them, kissing and touching might be separate categories of sensory-based experience that are included in a more general category called relating. In that case, kissing and touching would both be at logical level 1 and the same level of abstraction from sensory-based experience, while relating would be at logical level 2. From these few examples, we see that kiss and touch could be either at same logical level or at different logical levels, depending on how a particular person categorizes their experience. This demonstrates clearly that logical levels are relative, not absolute, and they can't be determined from content alone. Logical levels are independent of content. They result from how a particular person categorizes. Additional complexity. For simplicity, I have assumed that all members of a category are the same logical level. But this is not necessarily true. For instance, the category things that I can think about could include memories or images or physical objects that are sensory-based, very general, abstract concepts like truth or beauty, and all the possible categories in between. For instance, if you have a computer, you know that you can put many different items into the same folder on your desktop. A folder is a category of things, and it can hold a photo or sound recording, which is certain scope of experience. A document which is a description of a scope of experience, or even another folder containing other different items. A folder titled Miscellaneous may have nothing in common except the criterion that they are cluttering up your desktop. And you aren't using them right now, so you put them all in a folder to clear space for other work. When a category includes members at different logical levels, we can take any two of them and determine if they are related by categorical inclusion. For instance, if we use the category things that I can think of, mentioned above, we could take a specific memory and truth and find out if they are related by categorical inclusion. Usually it would be a member of category things that are true, but someone else might have a memory that they are uncertain about whether it happened or not, so that wouldn't be included in truth, but instead in a different category that we might call uncertainty. We can even say, if that memory is true, then it can be included in the category truth to indicate the difference in logical levels between them. We can always examine an experience and a category to find out if the experience can be included in the category. In the same way, we can examine any two categories and determine if one is included as an example of the other. This is something that we do many times, every day without thinking about it. If I say, that was a good movie, that includes a specific scope of experience in the category good movie. If I say, I seldom watch movies, that includes category movies in the more general category, things that I seldom do. Things that I seldom do is a subcategory of things that I do, for a total of 3 levels. If I say, I want to do several errands today, some quick and some that will take longer, there are 3 logical levels. Errands is a category with 2 subdivisions, quick and longer. And errands is a category included in the larger category, things I want to do today. Another aspect of multiple logical levels is that the smaller included levels become presupposed. In the previous paragraph, errands and the smaller included categories, quick and longer, are presupposed. In ordinary communication, this causes no trouble, because both the speaker and the listener already presuppose those categories. However, the same logical structure can be used to install presuppositions that the listener does not already have, so this kind of communication is very hypnotic. Sure. However, the same logical structure can be used to install presuppositions that the listener does not already have. So this kind of communication is very hypnotic. For instance, in the following short piece from a Virginia satire, Meditation, there are 6 logical levels of presupposition. As we come fully in touch with our capacity, inborn in all of us, to choose out of all we have at this moment that which fits us well